Hello everyone, we are here today to talk with you about our experience in making our Apple Arcade game Secret Oops, a very unique experience made in augmented reality and multiplayer. So briefly, a brief introduction about myself and our team. I am Mauro Fanelli, I am CEO and creative director of Mixbag. Mixbag is an Italian indie dev studio that was founded in 2013. We ship games on a lot of platforms, from PlayStation 4 to mobile to Nintendo Switch, Nintendo 3DS, Xbox One, basically every platform under the sun during the year. We usually work with strong connection to platform holders, so with Apple, PlayStation, Nintendo, and Microsoft directly. And when I focus on original and unconventional gameplay and new technologies. Here you can see some games that we developed internally and published internally, and some games that we ported and published on different platforms. Since we have very little time, I'll go very fast and skip to our new game. Our latest game is Secret Oops, and it's an Apple Arcade exclusive that was launched, the first version was launched in late January of 2020. Here is a brief trailer so you can have a better idea of what the game is all about. Okay, so what is Secret Oops? Secret Oops are groundbreaking, cooperative, local, multiplayer augmented reality game where there is Charles, this dumb spy that is also the best spy in the world, but actually he gets caught continuously by alarms and lasers and guards. And basically players are the guy behind the scene that work on hacking the various security systems to save Charles and make sure that the world gets saved once again. It's a game for 1 to 4 players. You play in augmented reality on a shared world map. It's an Apple Arcade exclusive. Here you can see some links to the game, to our website. And obviously the game is also playable on more traditional platforms, so on Mac and Apple TV, or without using augmented reality, you can play just using touch controls on iPhone and iPads. Let's go back a little bit in time. This is actually the very first presentation of Secret Oops. Back then the pitch was called Spy, and we worked on it in early 2018, so more than 2 years ago actually. Back then, this is a very interesting thing, the game was not meant to be for augmented reality and was not meant to be for mobile platforms, because actually it was a PlayStation pitch originally. We actually pitched the game, an original concept, to PlayStation as a PlayLink game. If you remember, PlayLink was that technology that using that you could play PlayStation 4 games using your phone, so you can just get with some friends and play multiplayer games on your phones connected to a PlayStation 4. It was a very cool concept, and when we saw it, we were like, okay, we can do something cool with that and pitch it to PlayStation. So we worked on 3 different concepts back then. One of them was Spy. So we pitched it to Sony. We were in talk with them for some months, but sadly in the end it was not meant to be. So what happened next? Since we really love the concept, we tried to twist it in a different way, and we thought, okay, augmented reality would be great with this kind of game because you can see the map of the game in the real world, you can interact with your phone, you can move around, we can do a lot of interesting stuff. So what we did was we kept the original concept about the dumb spy and the guy trying to save him, and we added augmented reality to it, and we tried to rework the game to work around augmented reality as a concept. And it worked quite well. So actually we pitched the game to Apple. Apple really liked it, and we got signed up for the Apple Arcade service, and the game is now a full Apple Arcade exclusive. Some information about the project. So in the end, the Secret Loop is now tailor-made for Apple technologies, so we try to use everything that iPhones and iPads and macOS has at your disposal. The game is actually made in Unity 2019.2. We launched the game on iOS, iPadOS, tvOS, and macOS, so all the platforms supported by Apple Arcade. We use some pretty interesting technologies, like for all the augmented reality part, we're using ARKit 3, obviously, from Apple, on AR Foundation from Unity. And we're using the lightweight rendering pipeline. Back then, actually, it was still called lightweight rendering pipeline. It was renamed to Universal Render Pipeline just when we were working on the game, and we've been, as you can imagine, very happy about that change. The game offers both augmented reality gameplay and more traditional gameplay. So yes, you can play in augmented reality with your friends, but you can also play on an Apple TV using a controller, or on a Mac using, a mouse and a keyboard. Everything mixed together, obviously. So you can play, some players can play in augmented reality, some other players can play in more traditional ways. We support from 1 to 4 players. The game works on a local network, basically, so you can play using Wi-Fi or using Bluetooth if you don't have a Wi-Fi network around. It's quite a big project, since around 45 people working on the game in different capacity at different times. We had an internal team, obviously, working on the game, but we also had some outsourcing about some graphics, animations, and audio. It's a complex game, but actually we made it quite fast, because it was, for the first release, it was around a 7 months productions, and it took around 13 months for the full game release. Right now, we first released the base game. Obviously, it's included the first 2 world and 35 levels, but then we released 3 DLC. The game is now complete, so we are about to release the next DLC very soon, and it will be the last one content-wise, but we will sure add some more gameplay and some surprises in the future for our players. So, okay, you can look at the game and think, okay, this is, quite easy, because it's just people touching the screen and disabling stuff, interacting with stuff in the game. But actually, this is a crazy complex game to make. For sure, it's the most complex game that we as a team have ever worked on. Why? Because, okay, first of all, it's network multiplayer. So we have to deal on all the networking stuff between different devices. Then it's a game that proposes a shared augmented reality world, and it's very tough to just have different devices pointing in the same way, and everyone has to watch and see the same thing at the same time. We also have to support both augmented reality and non-augmented reality gameplay, so the game must work in augmented reality but also with more traditional control system. We have to support for very different platforms, because we are supporting from iPhones, iPad, Apple TV, and a lot of Macs. We wanted to have a very high-end cartoon graphics and animations. So we really wanted to have top-notch visual presentation in the game and really try to push the medium. We had the support from mobile to computer hardware. Obviously, going on mobile, we have various performance and restraints, and we have power and battery constraints. You can push the hardware a lot, but then you will have battery consuming very fast, so you have to optimize a lot. Also, doing UI in AR is totally different than doing normal UI. So we had to think about a lot of different problems. We also have a lot of content because it's 5 game worlds with 80 levels, and it might sound not so much, but actually considering all the different ways you can play the game, it's probably around 10 hours of gameplay, so it's quite long and it has huge replayability with friends. Also, we have to deal with audio in augmented reality, and it's not easy stuff, since you basically have to come up with something that works with multiple players in augmented reality. And we support 4 different control systems, so augmented reality gameplay, touch controls without augmented reality, joypad, and then mouse and keyboard for Macs. The other thing is that if you look around, there are very few multiplayer AR games with a shared world between players. So basically, it was a blank canvas for us. We had to experiment a lot and came up with new solutions to problems that very few people had tackled before. How do we make it in the end? First of all, there is no silver bullet about that. There is no solution like, okay, we did that and everything went smoothly. No, it doesn't work that way. First of all, we had a very good team working on the game with lots of experience in shipping games on multiple platforms and mobile platforms. We shipped games on like 7 platforms at the same time in the past, so we already knew what kind of problems we may have in dealing on very different platforms at the same time. We also had a very good pipeline for fast iteration times. It was crucial because for an augmented reality game, you really have to test it in AR, which means that you need to have build ready and install on the devices. And on a game like that, it can take up to 1 hour to have a build. So as you can think, it's iteration times, having low iteration times is crucial. Also, we luckily had great support from our partners and from Apple. So actually, Apple got us in touch with some internal departments, so we were able to speak directly with the Game Center team, with ARKit team. They give us a lot of advices on how to progress in the game, and it's been incredibly useful. Also, this is such a unique game, and I want to stress that it's almost impossible to do this kind of game without having a strong support from a platform holder. In this case was Apple, and they really supported us quite very well on the game. Briefly, some tools that we use in making secret hoops. So our pipeline basically is, the engine is Unity, as I've already said. As a repository, we use SVN on a dedicated AWS machine that we control. We've used Discord for team communication internally. We've used Asana for task management, Mantis for backtracking, and especially Jenkins as a build machine on our Mac Mini. What Jenkins was doing, it was basically doing builds continuously for iOS. So, the testers and the game designer could test the game very fast. It was crucial and very important for the success of the game. Also, this is probably the tool that we use the most. It's called Miro, and it's basically an online, super huge canvas that you can use, infinite canvas. What we did was, use it for everything, from brainstorming to finding references to design, game design, organizing assets, timeline, everything. It's an incredible tool. We use it a lot. It's now a stable part of our pipeline for all the projects that we are making because it's super easy to use and incredibly powerful. So let's talk a little bit about the gameplay. As I've said, we have two different parts of the game. One is augmented reality, the one is more traditional gameplay experience. So this is a very complex part because we needed to have the game playable and fun in both ways. As you can imagine, augmented reality was our main focus. So first thing for us was try to make the game fun in augmented reality. In augmented reality game, propose you an augmented reality shared world. So you have this kind of game board on the table that you can interact with. The experience is very physical since the players move around a lot around the table, need to talk with each other, try to plan something and execute a plan. So imagine like you're playing a bit of Wii Sports. It's a bit of a same feeling because the game really requires you to move around a lot. It's very physical. Obviously, on a more traditional platform like a Mac or an Apple TV, you can't do that. So what we did is we tried to replicate the same experience using more traditional control system. So it's more about finger management and control management. You still have to figure it out how to do things, especially in multiplayer, and then you have to use your controller or your mouse or your touch to really execute it. It's really not the same thing. The game has really been born to be played in AR, but I think it's still pretty fun, and you can play it also with AR. So maybe a couple of people play in a more traditional way, a couple of people play in AR, and everything works. About the gameplay, the problem that we had. So first problem, and then some solutions. There are 80 levels in the game. The problem is that we couldn't do them automatically. The game doesn't scale automatically. It's not about adding more stuff and it works. It's about tailor-made solution for 1 player, 2 player, or 3 and 4 players. So actually we start with a single base, but then everything is handcrafted. The game must be playable in AR and non-AR, and as I already said, it must work on very different platform with 4 different control systems. So what we did is like, okay, everything is handcrafted. So we started with 80 levels and then we did everything by hands. So actually there are 240 levels in the game actually. So the level for 1 player is different from the same level for 2 or 3 players because hazard and interaction are different. So as you can imagine, is a ton of work, but there is no easy way to do that. The game, how it is made, you just can't do it automatically. You really need to have game designers doing it by hand. So same level base, different configurations. Then we did lots of testing, actually, which required to have builds ready very fast and installed on iOS. Constant testing, yeah. As I already said, we had this Mac Mini churning out iOS builds, then uploading them to our remote server, and you can just download them whenever you are on your iOS device and test it. It was extremely important to have this kind of fast iteration. So all the pipeline worked very well, and it was very important to have it because you really can test an AR game inside the Unity editor. You can now with Mars and some stuff, but back then we didn't have tool like that. So we really needed to do it by hand. Networking, it was another one of the very big problems that we have to tackle. First, we need to have very low latency. Each player plays in the same room, in the same AR world, but on different devices. But they need to see the things happening in real time. So what we did was make a custom-made UDP networking solution with a very nice automatic matchmaker. So if you are in the same room or the same network, you just find the other players and you can play. But actually we had to scrub it out and implement everything using Game Center. And since the game works on Game Center, we have to support Wi-Fi and also Bluetooth. Obviously, the problem is that Bluetooth is a lot more limited for latency and for bandwidth compared to Wi-Fi. So we really had to rewrite a lot of stuff, rewrite all the networking implementation and make sure it worked also on Bluetooth. It was a very, very long process, but we pulled it out in the end, and we had very good support from the Game Center team helping us, on some low-level stuff. The other problem is augmented reality, obviously. We need to have up to 4 players playing in the same virtual board with exact positioning. This is very, very tricky to do. Very few games do that because it's a very tricky problem to tackle. The solution was using ARKit collaborative session and exchanging data between the different platforms, so you can just position your world and every player see the same stuff. But sadly we had to scrap that because we tried to implement it in a lot of ways. The problem is that passing data around requires too much data. We have too much data to pass around when we pass the map around. And when we switched our networking solution, especially on Bluetooth, it was not doable. So we really had to scrap it. And now we are using a good old marker that you can print. It's not as fancy, but it works. But we really hope to bring back the ARKit collaborative session technology because it looked awesome. So if in the future we can optimize more and pull it off, we will for sure do it. Another problem, the audio. So you're playing audio basically from different devices in the same room in augmented reality, and people tend to play very close to each other. It's tricky to make sure that all the networking stuff is properly synchronized, and you need to have very low latency on audio or it kind of sounds off, especially with music. If it's not perfectly synchronized between devices, it's really bad. So what was our solution? First of all, using what we call the King system audio. So basically we select a device at the beginning of the game, the most powerful one audio-wise, and we play the music and some audio only to that devices. On the other devices, we play only sound effects, so not the main music and the main themes. And we have something that we call soundscapes. Basically, soundscapes are, different audio tracks that can be played for mood of a level, and they may not be perfectly synchronized, but they still work well together. So each device play a different track, and they kind of blend, and it works quite well. Another problem, the graphics. So, as we already said, we really wanted to have very, very high quality visuals with great animations and great graphics. But we are on mobile, so we have we have to make sure that power is limited, and we have huge battery constraint and thermal constraints. If your devices became too hot, it just throttle, so it brings down performances, and then everything is a mess. Also, the problem is the game is in augmented reality, and just enabling augmented reality has an impact on performances, especially on older devices without dedicated hardware, about AR and image recognition and image processing. So what happens is it's difficult to give you a ballpark, but just by enabling AR performances, you can get less performance from the hardware. The solution, okay, luckily iPhone's hardware packs a serious punch. So our baseline was iPhone 6s, and it's still an incredible capable device, CPU and GPU wise, and it's a device from 5 years ago basically. And if you look at the latest iPhone, they are just amazing. They pack a lot of power, CPU and GPU wise, so you can process a lot of data on that. Also, we optimize a lot And we use, as already said, the lightweight render pipeline to have, to try to extract the best performances possible from the graphics pipeline. Also, we use a lower resolution 3D frame buffer in the game. So depending on the device, we scale down the resolution of the 3D rendering. So the UI remains crisp because it's full resolution, but 3D graphics get scaled down. Actually, we never go lower than 60% of the full frame buffer, and we go up to 100% to newer devices. The thing is that you can't really notice it because actually on Retina display, really going full resolution doesn't make a lot of sense because you can just scale it down, use less power, and no one actually really notice if you don't go too low. Also, in the end, we capped the game at 30 FPS. Why? Actually, Secret Oops can run at 60 FPS also on other platforms, so you can really play it at 60 FPS. And yeah, we know 60 FPS in AR experience is probably better. The problem is that running a game at 60 FPS consumes a lot of battery, and at the same time, it really eat up the devices a lot. So what we found is that after 2 or 3 minutes of game, or 10 minutes, your device is so hot that it's throttling down, so the game starts dropping frames, getting lower, so 45, 30 FPS, and then it keeps oscillating around. And since it's tried to render at 60 FPS, you can never recover it, actually. We tried different solution, adaptive solution, try to scale the performance in different way. But in the end, we just decided, okay, let's cap it at 30 FPS because augmented reality is really demanding, the graphics are really demanding, and what happened is that no one really complained about that. So it was the best thing to do back then. No one said us, okay, the game is running 30 FPS. So it was a very, very, very good choice. About the graphics, some information. So we are actually pushing a lot of vertex in the game, because a lot of vertices in the game, because we are pushing around 5K polygons per frame, because we want to have very, very rounded and cartoon, look, and to do that we had to, push a lot of polygons. Basically, we have almost no hard edges. Everything is smoothed out, and it requires a lot more polygon than just using hard edges. But it was one of the only way to achieve the look that we wanted. We have basically all static geometry in the game, aside from the character and a couple of other stuff. So we try to keep the draw calls as lower as possible. We are using the SRT batcher from the lightweight render pipeline, and it does a very, very good job in batching, and lowering all the draw calls cost from CPU to GPU. It works very well, and it saves us important milliseconds while rendering the frame. As already said multiple times, we are using the lightweight render pipeline, now URP. It has some limitations, but in the end, it really performed very well for us. Also, all lighting in the game is actually baked, so it's all baked light maps on static geometry with a lot of reflection probes and light probes in the game. We are using a very low number of real-time lights, so we basically have one directional light and a very low number of point lights, all baked in the environment and just influencing the characters and all the moving part in the level. Also, we worked a lot on optimizing the materials and shaders in the game, and also on the textures to keep the bandwidth requirement very low. Basically, all levels just use one 2K texture set that you can see an example here. So what we did, this is a clever trick. We use a lot of gradients, so we can just paint some geometry in a clever way with clever UV texturing, and so we can have some smooth gradients around the levels and some high quality texturing. It works quite well to achieve the look that we wanted. As already said, we also use a lot of custom-made shaders in the game. All the shaders were made using shader graph, basically. And we achieved some very cool results. As you can see, we have caustics, real-time caustic on some level, distortion from water, animated water, with refractions and some extra effects. We have fake reflection glasses. This is just to tell you something of the graphic effect that we implemented in the game. There is a lot more stuff. If you play the game, you can see some very clever shader stuff going around, and it performs very well. Another important thing, we wanted to have a very detailed character with awesome animations. So actually we partnered with a proper animation studio, Maga, from Italy. They are used to do CG cartoon, so they really know their stuff, and they helped us in making and animating Charles, our main character, and Robo Spice, the other character in the game. How is Charles made? Well, it's quite high poly for a mobile game, since we're using around 14K polygons and it's props excluded, so it's only the Charles mesh without the glasses or all the added stuff that you can see. The character used 2K texture sets for body, head, hands, and another texture set for props. So actually, it's a very detailed texture. We use classic PBR rendering. So we have all the classic maps, albedo, normal, metallic, roughness to achieve the look that we want. Interesting thing is that the actual model of Charles, 3D model, used both in game and the CG cinematic that we have in the game, and the CG cinematic is actually rendered using Unity high definition render pipeline. You can see an example down on the right, and it looks quite awesome, where the other two examples are the more how they're used in the game actually. Also, the rigging is very complex, since we use 120 bones for the character, and that's a lot of bones. Is unusual for a mobile game to use such an high amount of bones on one character. But the thing is that we wanted to have very cool squash and stretch animations, and this is how the animations look like. As you can see, to achieve these kind of effects, you really have to have a very complex bone setup to have the freedom to do with the players whenever you want with the character. Also, we obviously use blend shapes for the facial expression, and so we have very detailed facial expression in the game. These are some other animation examples. As you can see, really wanted some cool animations in the game, something that you usually only see in cartoons and not in games. We actually had a lot of freedom, because we have total control on what the character does in the game. The gameplay is quite unconventional, so the player doesn't control the character directly. So we have, we can take some liberties with blendings and some stuff like that. So we could really push for very complex movements. Here are an example. Is an example of our animation for our robot guards. So as you can see, they are a bit simpler, but we wanted to have awesome animations, very fluid animation, cartoonist animation on our robot guards too. We wanted them to look like, a bit like dogs, and as you can see, we try to emphasize some, proportion, and so they really look like little dogs running around. So in the end, as I said, Secret Roots is now available on Apple Arcade. We launched the game on 31 of January 2020. You can just download it, play it, if you want. I really hope you want to play it. It's a very, very unique experience, and we've been very happy on how it turned out. In the end, just a little recap, what went well? Well, this is a very fun, unique, and ambitious augmented reality experience. So we are very glad to have been able to work on it and do this game. And it's very, very complex project. We think it offers great graphics and animation, and it's a great technical achievement. It was tough, but the game runs very well. We are really happy about the look and about how it performs on the devices. Also, we got a lot of experience in augmented reality development and multiplayer game development. What didn't went so well actually? Sadly, we had to drop some of the main features for technical limitation, basically all the collaborative sessions mapping. We really hope to bring it back in the future. We really hope so. Also, we had to rewrite all the networking, and it took a lot of time. Actually, it took months to rewrite it properly. And also the game really required a lot more trial and error and testing than we anticipated in the beginning. We had to iterate a lot more because sometimes something that we tried to do didn't work well, and we just had to redo it by scratch. But in the end, we made it. So thank you. I really hope that you enjoyed this post-mortem. We tried to squeeze it as much as possible. We had little time. And if you want to get in touch with us, just send an email or visit our website. And that's all from Mixed Bag. Bye.